Welcome to my channel. Today we are going to discuss about Cbse 11th Chemistry chapter Chemical Bonding and Molecular Structure. Eleventh standard Cbse students, those who study in chemistry, please watch this part. Please subscribe my channel. The first question is, we explain the formation of a chemical bond. A chemical bond is an attractive force that bonds the constituents of a chemical species together. So, many theories are suggested for chemical bond formation, such as valence cells electron pair repulsion theory, electronic theory, molecular orbital theory, and valence bond theory. The next question is, what is the favorable factors for the formation of an ionic bond? The formation of an ionic bond takes place through the transfer of one or more electrons from one atom to another. Thus, ionic bond formation depends on the flexibility of the natural atoms to lose or gain electrons. So the formation of an ionic bond also depends on the lattice energy of the compound which is formed. The factors that are favorable for ionic bond formation is high electron affinity of atoms of nonmetals, the high lattice energy of the compound which is formed, low ionization enthalpy of an atom of metal. Next question is, define the octet rule. What is its significance and the limitations? Octet rule says atoms can combine either by transfer of valence electrons from one atom to another or by sharing their valence electrons in order to achieve the nearest inner gas configuration by having an octet in their valence shell. So octet rule explains chemical bond formation depending upon the nature of the element. The following are the limitations. One is, octet rule fails to predict the relative stability and the shape of the molecules. It is based on the inert nature of the noble gases. But some inert gases, says krypton and xenon, form compounds like KrF2, XgF2, etc. And for elements beyond the third period, the octet rule cannot be applied. Elements present beyond the third period have more than 8 valence electrons surrounding the central atom. Examples, S of 6 and P of 6, etc. Next question, how do you express the bond strength and in terms of bond order? The extent of bonding which occurs between two atoms while forming a molecule is represented by the strength. As the bond strength increases, the bond becomes stronger and the bond order increases. So now we are going to see about bond length. Bond length is defined as the equilibrium distance between the nuclei of two bonds atom in a molecule. Next question, arrange the bonds in order of increasing ionic character in the molecules. LiF, K2O, N2, SO2 and ClF3. The ionic character of a molecule depends on the difference in electronegativity between constituents atoms. So, the higher the difference is, the higher the ionic character of the molecule will be. So, the required order of the ionic character of the given molecule is so LiF greater than K2O greater than the following order is like that. Which out of ammonia and NF3 has higher dipole moment and why? Ammonia atom is central atom of NF3 and NH3. Central atom has one lower pair and is having 3 bond pair. Thus, for both the shape is pyramidal. As the F atom has more electronegativity than the H atom, NF3 should have a higher dipole moment than NH3. But the dipole moment of NH3 is 1.46 D, which is higher than the dipole moment of NF3, which is 0.24. It gets clear from the direction of dipole moment of individual bonds in NF3 and NH3. Let's go see distinguish between a sigma and a pi bond. Pi bond is formed by lateral overlapping orbitals, whereas sigma bond is formed by end-to-end overlapping orbitals. Pi bond is a comparatively weak bond. Sigma bond is comparatively strong bond. There is only one overlapping orbital in P-B. The overlapping orbitals are S-S, S-P and PP. Pi bond rotations are pi bond is restricted. In case of sigma bond, it is possible around sigma bonds. Rotation is possible. Pi bond electron cloud is not symmetrical about the line joining two nuclei. In case of sigma bond, electron cloud is symmetrical about the line joining two nuclei. Then pi bond has two electron clouds, one above the plane of the atomic nuclei and one below the plane of atomic nuclei. Whereas sigma bond has one electron cloud and that is symmetrical about the inner nuclei axis. Write the significance of plus minus sign shown in the representing the orbitals. Generally, molecular orbitals are represented by the wave function. Positive sign is representing the molecular orbital, indicates positive wave function, and negative sign represents the molecular orbital, negative sign function. So that indicates negative wave function. Write the important conditions require the linear combination of atomic orbitals to form molecular orbitals. The first one is the joining of atomic orbitals must have approximately the same energy. This implies in a homonuclear molecule, the oneness orbital of one atom can join with the oneness orbital of the another atom, but cannot join with the 2s orbital. Second one is the joining atomic orbitals must have legitimate orientations to ensure the maximum overlap. Third one is the overlapping must be to a large extent. Thank you.